Yo, what's up everybody? Today we're gonna jump right in because I want this to be a quicker video, and we're gonna do the Floyd cycle detection. Wow, this is a smart thing and I had no idea why it works. So let's start off with explaining what Floyd cycle is. So let's say oh, I don't like that mouse part. Okay, let's say you are stuck in a cave. Well, actually, but before we get to our analogies, what it's trying to see if if you have like a linked list or something, is there a cycle here? So like, does it do something like this? And the way to do it is you have one guy start. So you have one guy, one pointer, move 2 steps at a time, and the other pointer move 1 step at a time. So they first start off here, then slower one goes here, faster one goes here, and then okay, I'll just go like this. So slower one here. So slower one moves 1 at a time, and then faster one moves 2 at a time. And then this is going to move 2 at a time. And then he'll move 1. It's kind of getting messy here. And then they meet here, actually. And notice that like the jumps happen at the same time. And so the question to be asked is, why does this work? Okay, I'll first give you intuition for why this works, then solidify it with a some math for why this works. So let's say you and your friend are stuck in a cave, and this cave is a circle like this, and your friend says, I bet this is a circle, and we're walking in a circle, and we're gonna die here. And the other friend says, no, there's a way out. Okay, so you don't know, and you want to figure out if there's a way out of the cave. And if there is a way out, let's say like you can't go in to save your friend, so you want your friend to be able to get out also. So you both have to be moving. So we're gonna do the one friend goes 2 steps at a time, the other friend goes 1 step at a time. And also they can't see each other unless they step on the same rock. Okay, that part, like, yeah, they have to step on the same rock, right? It's to make an analogy to these linked lists. They have to be in the same, they have to be the same pointer. So anyway, the friend starts moving faster, the other friend moves slower. Regardless, we're gonna eventually end up, just bear with me here, in a scenario where the slow guy's here and the faster guy is behind him, right? And like almost gonna reach him, like almost gonna surpass him. So we really have 2 options. It could be slow guy here, and there's one in between. Sorry, let's just start off with this. So slow and fast are here. If they're right behind each other, then the next time, the next steps they take, they will be on the same one. So this is scenario number 1. Then we have scenario number 2, where we have first and a missing block, or a block in between them, and second. Then what's going to happen is he's going to go here, he's going to go here. So then we get F and S, and then we get to the same situation as number 1. Okay, and basically I want you to see intuitively that these are these steps, like these 2 scenarios, or even just this one, is the one that they all come back to, even if F, let's say there's 2 in between them, right? Because we know F is eventually going to surpass him, right? And this is also kind of giving intuition why you only need to go through this 1 time. Because like F is going to be, let's say, here, 2 away. Okay? And so then F is like Okay, I could jump 2 and then you jump 1. Okay, so then we get F blank S. And look, we are in number 2 again. And so the idea is that wherever they start this trend, like by the time they're halfway point, which is like here, S is going to be here, and then the fast guy is going to be all the way here. Right, and then so now, so like remember the fast guy was already in front of him here, or sorry, here, and then he got all the way around, and the slow guy's only here. Okay, so that was just the first time. That was like the first time the fast guy's going around. Then the slow guy is gonna move slow, and the fast guy is gonna be going faster. And then slow guy moves a little more, and then faster guy is like coming right in, and basically they if it's a loop, they should meet at about the starting point here. They should meet here because faster guy can make 2 loops by the time S makes 1. So this is O of n times for n being the size of this. And so, like I said before, something I struggle with to understand is like the off by 1 errors. What if fast just skipped right over the slow guy and then continued, and then it was an infinite loop? And that's what I'm trying to show here, that it can't happen. That that scenario where he skips, where the fast guy skips over the slow and just that pattern continues forever, can't happen. Like, I'm showing you all the scenarios here, and it just, like, it can't happen intuitively because they're all like turning back to one of these scenarios. Okay, now time for a mathy explanation. So let's just be arbitrary here. Let's say we have a length of loop is n, and let's say that fast guy can start anywhere, just to be arbitrary. So let's say he could start off at m or something, and then slow guy starts off at 0. He'll be at the beginning, and then we could have this. So fast guy's distance in terms of time is going to be where he started plus 2 times t over modulus n. That's where he is. And then slow guy is going to be t mod n. Okay? And then, do you see when they equal, when they are guaranteed to equal, mod n, we just get m plus t equals 0 mod n. So basically m was a constant, and so m is like wherever the faster guy started. Let's draw a new circle. So we have this new cave. So m is wherever the starting point is going to be here. This is 0, and let's say faster guy started here. This is faster guy's starting point. Okay, so that's the fast guy's starting point, which is also m. I should have changed. I'll make that m. So that's m. So what it's saying is it needs to go this is the amount it needs to go. It needs to go t to catch up to it. for them to be equal. Or actually, rather, some multiple of t. So t could actually be like this. Okay, and it's eventually, like I said, gonna it's only the slow one's only gonna go through once, and then the fast is eventually gonna catch up to it wherever it is. Even if m starts off in the worst case up here, or yeah, it'll just take 2 loops max for the fast, and slow only 1. So that's why it's O(n). So back to this math equation, m plus t is congruent to 0. Right, so t could be n minus m, but t could also be 2 loops minus m. But that's it. And I think I've showed through intuition why it's at most 2. Okay, thanks for watching this. I hope you understand the Floyd cycle detection algorithm much better now. Okay, thanks. Bye. See you in the next video.